Sure. So I guess that brings us back to the world of XPUs, and the news this time around is that Microsoft is deploying their second generation of their Maya 200 accelerator. They didn't disclose a great deal of detail, but I mean, it is a 3 nanometer design. I think they said it was 750 watts. They did some performance comparisons that I'll leave to you, Joe.
They gave some raw throughput for FP4 and FP8 without giving exact numbers, just to put it in context. It's about the same as Nvidia Blackwell, but Nvidia Blackwell isn't hitting those performance at a 750 watt range. So I think that's its big advantage, is that it's going to be more power efficient for a given level of raw throughput. They're going to have to submit ML-perf results or have some additional information disclosed before we can assess, like, in terms of actual throughput, how good is this particular chip?
Yeah, and then just in terms of market impact, I mean, they only talked about deploying it in one data center initially and a second data center, kind of coming soon. So the volumes are quite small at this stage. I haven't seen anything definitive kind of from the supply chain on the actual volumes they're going to deploy this year. So I think this is still going to be quite small relative to the scale of, a AWS Trainium, or of course Google TPUs. I mean, Amazon's going to deploy millions of Trainium 3s this year. Google's going to deploy millions of TPUs this year. I don't think Microsoft's going to be on the same scale. I'm not even sure they're going to be within an order of magnitude.
Yeah, the other thing is the Tratium and the TPU, they're also available to anybody to use as instances. And it's not that that's going to be the big driving factor, but it speaks to the maturity of the software and the maturity of the silicon, where they can open it up to other folks. Whereas Maya 100, it's not even clear they deployed it. And Maya 200, I would assume the first customer, if any major customer, would be OpenAI or Azure running OpenAI models. So it's still kind of a question mark in terms of its actual viability.
Yeah, but it's definitely progress. They didn't, unfortunately, disclose a lot of detail, except they kind of alluded to it leveraging a lot of the technology from, I assume it's still kind of the Ethernet-based interconnect, but we don't know anything about speeds and feeds as far as the interconnect is concerned.
Right. So it does. They did state that it uses Ethernet. It's uniformly Ethernet, so you can build up a quad with 4 fully interconnected chips. So that sounds like a point-to-point Ethernet link, and that would be the scale up. And for scaling out, you would stay in the Ethernet domain, and you can, I want to say it's 6,144, which is one quad, which is a quad times 1,536. They have this uniform fabric for scaling up and out. That's the advantage I see to that is operational. They don't have to worry about having the equivalent of an NVLink switch, because they're doing full point-to-point links at the smallest granule, and then above that they could use standard Ethernet components.
Yeah, and that seems to fit also from an inference standpoint with MOE and kind of how inference is being done with some of the newer models. It should work pretty well from an inference workload perspective. Presumably they're not going to be training large models on Maya.
Well, they specifically said this is for inference, and the largest type they support is BF16, and the performance isn't great. It's less than half that of FP8. So yeah, I think it's fair to say they're not doing any training or expect anybody to do any training with this. And
Yeah,
that
so
definitely
that
simplifies their job a lot.
yeah, so I mean that takes the pressure off the scale up interconnect, and they
Right.
can build, as you say, something that is easier to build out with one consistent interconnect technology across the cluster.
Right. And then we recently talked about Grok in a previous episode or two, and one of the things Grok did was they integrated a lot of memory on chip, and Maya 200 integrates about the same amount of on-chip memory, and that should help both with performance and power efficiency. So throughput divided by power. So I made note of that as a key feature.
Interesting. And it didn't drive the power way up either. So, of course, they are in 3 nanometer. And so they're slightly ahead of NVIDIA from that perspective since Rubin isn't yet being deployed.
At the same time, Rubin, using NVIDIA's numbers, they're promising this 10x improvement in inference efficiency. Until somebody gives some actual hard numbers, it's hard to assess any of these. If we accept that at face value, then whatever gain Microsoft has over, I was about to say Hopper, over Blackwell, they're just going to be leapfrogged by NVIDIA.
Yeah, I mean, at the same time, I think I mentioned last time NVIDIA, I think it was for Dynamo, they showed that they had increased the performance of Blackwell by 2.8x just in software. And so, I mean, these numbers get thrown around like the 10x number, but then you have to kind of go back and say, okay, but meanwhile, the Blackwell software improvements have increased the Blackwell baseline number. And so what's the real multiple with equivalent software?
Right. And then there's what NVIDIA can achieve, because they're motivated to pull out every stop to make their product look the best, whereas their customer maybe has time pressure and they have to get their next frontier model out before their competitor does, and they may spend less time using all of the WYSI features that would help them on a comparison in terms of either throughput or power.
Yeah, I think specifically you mentioned sparsity last time around as being kind of part of what NVIDIA has been quoting in terms of their performance numbers.
Right. Okay. Well, with that, Bob, I don't have anything else to discuss. Do you?
No, I think we're caught up for the moment.
All right. Well, that's great. Thanks, everybody, for listening. And if you want to keep up with us online, you can go to my site, npu.pub. I have a write-up of the Maya 200 there. And you can go to wheelersnetwork.com and see Bob's latest thoughts. With that, be well.
It's all about the Pentiums, baby.
Hi, you've been watching a segment from a longer Byrne-Wheeler report discussion. To watch the preceding segment, please click up here. To watch the next one, please click over here. You can subscribe by clicking this round orb. And to see another video in our series, please click down here.